Hello and welcome to week 5 of the C# 101 class. I'll be here and my name is Nelson. So today what we're going to do is we're going to take a look at some odds and ends really. I want to talk about exception handling, some basic debugging, enumerations. Let's toss in some more logical operators so we can get our if statements to be more succinct. That'll be awesome. And then we're going to be reviewing methods and talking about how we can use them to make our applications a lot more clean. Like I said before I started the recording, this week is to lull everyone into a false sense of security because next week we are going to be diving into a significantly more advanced topic. So the reason that I had this week kind of be a little much calmer than previous weeks is to just give people a chance to catch their breath and catch up and review things that they might be confused on. So let's go ahead and start off with the new stuff, because the new stuff I want to introduce today is pretty straightforward. There's not a whole lot to say about it. The first thing I want to do is let's talk about some enumerations. So in software that we write, we often run into situations where we may have a method or a variable that we want to be able to make it of a type, and we want to have that type only be one of X amount of values. So I'm sure that a lot of people here, like we've talked about Booleans. So my Boolean, and it can contain true and it can contain false, and that's all a Boolean can do. We run into situations where we want the similar behavior of a Boolean, where it can only contain one or two of a constant expression, but we want to have control over what kind of constant expressions we can put in. So I'm going to be introducing an example of a new type. What do I mean by a new type? Well, I mean that, you know how we have like floats and ints and bools and doubles and all that fun stuff that we've been using? Those are all types, and they allow us to create variables of those types. Well, an enumeration allows us to define a user-defined type, which is one of the kind of core aspects really to programming in C#. You're going to be spending a lot of time creating types. And there's a variety of different kinds of types. The only kind of type that we're going to be working with today are enumerations. Next week we'll be discovering or going over some other kinds of types we can put together. But enumerations will give us a really easy way to kind of see, okay, so this is how I create a custom type and this is what it does and blah blah blah. So they're lots of fun. So an enumeration is, again, it's kind of type, and we define it wherever a type definition is allowed. So again, you're just going to have to know the rules in this case. You're just going to have to memorize where it is that type definitions are allowed. And the easiest way to think of it is that types are allowed anywhere that really isn't a method. Now that's not necessarily true. There are other circumstances that types aren't allowed in, but for now, since we've already really talked about methods, the easiest way to describe it right now is we can define an enumeration anywhere that isn't a method. So let's take a look at what a definition of enumeration looks like. So I'm going to start off with an arbitrary enumeration. How about let's do a simple oh, wow. I had this example all in my head. I know exactly what it's going to do, but naming sometimes escapes me. So let's go ahead and give it an enumeration of thing. That's not a very good thing. How about extended Boolean? There we go. And extended Boolean is going to have 3 things inside of it. Those are going to be, how about true, false, and no value. Now in C# this isn't actually the best way to express a Boolean like this, but it is a very easy example to comprehend. What we're looking at is an enumeration definition. This definition, it's important to note its location. It's inside of the class program, which is perfectly allowed in C#. You can put types inside of classes. but it's outside of the main method. Now we wouldn't be allowed to define our enumeration inside the main method. So what's going on here? Well, we start off with a keyword, we put in an identifier, and we open up a curly. Again, that's a very similar, that happens a lot in C#. The syntax looks very similar to maybe like an if statement or a switch, or even what we have up here in line 3. So it's a very common pattern in C# syntax. By saying enum, enum is short for enumeration. And in case if anybody has heard the term enumerable by now, an enumeration is very different from an enumerable. They're not the same thing. In enumeration, this enum keyword defines a type. And the way that we describe the enumeration type to the compiler is that within our curly braces, we give it a comma-separated list of identifiers. And that's it. This code is not executable code. It doesn't do anything. In fact, you might even notice ReSharper darkening my definition of this enumeration because it's telling me, well, this actually doesn't do anything. So let's make it do something. Now that we've created our extended Boolean enumeration, I can create variables using that type, and I can create as many variables as I want that use this type. So I can say extended Boolean exBool1 and extended Boolean exBool2. So now you see an example of me using this type twice within a method. And what I'm doing here is I'm defining two variables, both that are of type extended Boolean. Now remember, extended Boolean is not something that comes from .NET or C# or anything like that. It's something that we've put in custom to meet whatever needs that we're trying to meet. So now that I have two extended Boolean variables of this type, it's important to note their constraints. Because an enumeration is all about providing a set. If you're familiar with math, it's providing a set of possible values. And a Boolean or a enumeration variable of this type may only ever be one of these three variables. So let's see what that looks like. I can say exBool equals extended Boolean dot false. Or I can say exBool2 equals extended Boolean true. I can also test for equality. For example, I could say if exBool1 equals no value, then tell the user that there was no value. 99% of the time, you're going to be using enumerations in this capacity. And what I mean by that is the assignment operator will allow you to assign a enumeration expression to our variable, an enumeration constant rather to our variable, and an equality operator will be able to tell us if our particular variable has a particular value. So the thing about enumerations, again, is that these variables can only ever contain these constants. So enumerations are really nothing more than providing a set of constants to typically describe some sort of state. Let's do another example. So we took a look at a fairly abstract concept of putting in an extended Boolean. Again, there's a better way to do this within C#, but it's out of scope. But there's a better example. Now, typically in web applications, wherever you see a drop-down, or even in normal programs, whenever you see a drop-down, you can, and when I say drop-down, I mean like a drop-down list. Like, for example, right up here, we have a drop-down list of different items, and the selected value may only be one of the items within the drop-down list. A lot of times, those come from enumerations. So, for example, we can go ahead and create an enumeration called marriage status, for example. And we can use this to describe, okay, is the user single, married, divorced, and so on and so on. We can just keep on going on and on and on and describe all the different marriage status states that a particular user can be in. So at this point, maybe we'll have a method called static marriage status get status from user. And what we can do here is I can say, okay, console writeLine status, and then we can write, okay, console writeLine, how about 1 is single and 2, 3. And then I can go ahead and accept input from a user, which in this case I'm going to be lazy and just say user input equals int.parse console readLine. Obviously we would want to do some more validation on that, but right now I'm not going to worry about it. And then I could say something like if user input equals 1, then return single. If user input equals 2, I'm going to put braces in there just to make, for people who may not be used to that syntax, return married. And then if user input equals 3, return divorced. And if the user input is not 1, 2, or 3, then we have an issue with, well, what do we return? I can go ahead and specify another enumeration value if I wanted to, and I can say not specified. And I'll return that by default if the user input is not 1, 2, or 3. So this method is made a lot more interesting than what it could have been if I did not have a enumeration. What would a person return if we didn't have enumerations to play with? Would you return an integer that just has a constant that's used throughout your program, just the number 1, 2, or 3 to determine these 3 values? Would you return a string that's set to these strings that you constantly have to compare to see if something is of one particular value? You could, but it wouldn't be very good practice. What we have here is a perfect example of a method that may very well return one of a specific finite set of values. So what I can do now is let's go ahead and enter a bool is looping equals true while is looping marriage status equals get status from user. I'll go ahead and split the definition and the declaration here for you guys. And then I can go ahead and say console writeLine, you are status. If they do not specify, then I'll go ahead and say is looping equals false, and then I'll say console writeLine program is finished, console read key. Now what I can do is I can sit here and I can specify the different statuses as much as I want, and my program gets that output. And then I can go ahead and put in a not specified, and it'll finish my program for me. So, just to recap, now that we've seen an example of some working code that takes advantage of the concept of enumerations, let's go ahead and recap them real fast. An enumeration is a user-defined type. A user-defined type is a type that isn't built into the language, but still follows the same rules as the types we've already been using, such as Boolean. Meaning, by defining a user-defined type, we are able to create variables of that type. We're also able to use them in return values and parameters and all that fun stuff, just as if it was a built-in type into the language. Next up, an enumeration, the definition of the enumeration, starts with the keyword enum, which is short for enumeration, then an identifier, then some curlies, and then a comma delineated list of other identifiers. These identifiers that you place within the enumeration are completely up to you. You may only put a finite amount within them. That's an important distinction. You can't put, you can't have a variable amount of items within an enumeration. If you're trying to solve a problem that requires you to have a variable amount of data, then you're better off using something like a list. By defining these identifiers within my enumeration definition, I'm constraining the value of any variable of this type to one of these four constants. Now, I call them constants in the English definition of the word. They're constant in that they will never change, and they are simply nothing more special than a named number. But they're not necessarily constants in the sense of the language itself. We haven't discussed constants, so that distinction isn't necessarily that important right now. What is important is that, again, whenever we create a variable of this type that we created, our own custom type, we can only have this variable be of one of these four values. Meaning that enumerations, when needed, considerably increase the readability of your code, because they allow us to sort of codify the concept of a value that can only be one of four things, or one of 5 things, or one of 10 things, or however many things you want to put in your enumeration. It's important to realize that enumerations really do come down to numbers, just like really anything else in programming. Meaning, if I go ahead and hover over one of these, is Visual Studio not going to do that for me? Nah, it's not going to do it for me. Each one of these things actually represents a number behind the scenes. Now, a lot of people use enumerations and they convert them in between to numbers and from numbers. I don't really like that, to be honest. I don't really like having a, what you can do is you can actually do a cast to and from numbers from enumerations to get the underlying values. I personally don't like it. I do it every now and then when it's required, but ultimately the most important thing to me is that you think of an enumeration as defining basically your own numbering system where you get to name the numbers. And having a correlation between this numbering system and something external to it typically results in code that may start to lose the benefit of using enumerations in the first place. You'll notice actually that's exactly why I wrote out this if statement like this. I really wanted to be very explicit about what number the user is entering and have that be manually converted into one of these values. It makes the code a lot more solid. That's not to say I couldn't go from a number to an enumeration value, because technically you can, and you will see that done, and occasionally I do it. But what I am saying is that when you're using enumerations, you should try to think of the values that you define here within your enumeration definition as being not within the same numbering system as something like decimal or hexadecimal. So again, enumerations, they're fixed upon compilation. Now that's not to say they're not flexible. Within code, you're always thinking, oh, I don't want to make this hard-coded, I don't want to make this hard-coded. Well, at the end of the day, there are so many situations where you would want enumerations, particularly things like marital status, or maybe what kind of type a thing is. Like, for example, you may have a product, a concept of a product within your code, and you might want to differentiate a product that is downloadable from a product that is physical. And although you can solve that problem using a variety of different constructs in C#, enumerations are particularly suited for those kinds of operations. Enumerations are also used in finite state machines, which finite state machines, by definition, are state machines that have a finite amount of states that don't change. And a state machine is just the concept of a piece of code that loops over and over and over again, and it knows what state it's in, and it changes its behavior based off what state it's in. In fact, I can write an example of that, as that's another very common use of enumerations. So I'm going to go ahead and nuke all this code, and I'm going to write another enumeration. In this enumeration, I'm going to go ahead and call it program state. And program state can be in the main menu, or the help menu, or it could be quitting. So these are the 3 states that I want my program to support. what I can do is now I can create a variable of program state called state. And I'll initially set state to main menu. Then I'll enter a while loop, and I'll say while state does not equal quitting. Then I want to, let's do a switch on state. Now, if the state is in the main menu, we'll do one thing. If the state is in the help menu, we'll do another thing. So, if we're in the main menu, I want to go ahead and say console write line 1 help 2 quit, and then I'll put a header up here just to make our code look pretty. Main menu, and then I'll say I'll go ahead and create an integer up here called user input, and I'll say user input equals int.parse console read line, and then if user input is 1, then I'm going to switch my program state to my help menu, and then I'm going to, that's all I'm going to do actually. If the user input is 2, then I'm going to switch the state into the quitting state, which if you recall will cause the program to quit, because that is the condition that we've specified inside of our while loops condition. If we're in the help menu, I'll go ahead and just put in a bogus help menu, and then I'll get some user input. How about this? I'll say help menu console write line, hit enter to go back. And then I'll say console.readline. And on readline, I'm not using it to collect any information from the user, I'm just using it to pause the program until the user hits the enter key. And once they do, I want to switch the program state back into the main menu. So now when I hit F5, I have my main menu. I can go into my help menu, which shows me my help menu. I can hit enter, I go back to my main menu. I can just do this all day. Or I can hit 2, which will quit the program. So this is a finite state machine, actually. I know that terminology sounds a little bit crazy and complicated, and you'll see it in a lot of artificial intelligence books and so on, but this is really what it boils down to. And enums are a perfect candidate for solving this problem because they allow us to have our program in a very clean way describe exactly what the program state is and to switch based off that state. Okay, so one quick shout out to people who are familiar with Java. C# enumerations behave very differently than Java enumerations. I just want to point that out. In Java enumerations, we can do a whole bunch of fun stuff with them. In C# enumerations, we're pretty much stuck to doing what I showed here. There's a couple more tricks we can do to enumerations, such as manually setting their backing numbers or changing the underlying type, but that's not important. What's important to understand about enumerations now is that we can use them to describe a finite set of potential values. And that's it. And it might seem very simple, and you might be wondering, when am I ever going to use it? And I can't answer that question, but what I can say is that eventually you will be sitting down programming and you'll be thinking to yourself, wait, I want to represent a finite set of values, and then you should use an enumeration. Alrighty. So I don't know what else to say about them, other than their academic definition. They represent a finite set of values. The biggest thing that I kind of wanted people to see here is kind of a precursor to next week, and that's an example of us creating our own type. Like I said, in C# there are many different kinds of types, but one of them is an enumeration, and the types that we can define allow us to extend our program and make it more succinct and comprehensible by providing some level of abstraction. And in this case, we are abstracting over basic numbers and giving them names. And that's all we're doing right here. It's a very simple construct, but it's a very powerful idea that we are able to define something up here outside of main, even outside of program if we wanted to, that allows us to create variables of that type. Okay, so that's about that. Let's move on. Okay, so exception handling. Exception handling is a very complex topic. The only thing that I want to do here is show you guys that you can handle exceptions and how to work with that. And what exceptions are, and that if you ever see an exception, don't freak out and just give up coding, because they will happen, and they will happen to you a lot. An exception is a type of error. We've already seen many examples of compile time errors. Remember how even all the way back in the first week we talked about the difference between compile time and runtime. Compile time is what happens within Visual Studio as we type our code, and runtime happens whenever a user opens your application. So you might see an example of a compile time error by, well, just putting in some invalid syntax. For example, right here, we are missing a required curly brace. And that's going to result in a compile time error. And we know it's a compile time error because we get a bunch of squiglified code, ReSharper freaks out and turns all our code red, and if we tried to hit F5, we would get build errors. And then our error list would pop up. So this is a compile time error. But that's not the only place that errors can happen within your code. Most of the time you'll be dealing with exceptions. So let's go ahead and I'm going to go ahead and write code that will produce an exception. We've actually already seen an example of it. So if I go ahead, I wonder if it's warning me. Never mind. Okay, so if I go ahead and run this in my debugger, we get an exception. What happens when you run into an exception in your code while you're debugging is Visual Studio will go ahead and minimize your application and open up its debugger. The debugger will highlight the current line of code that caused the exception to happen, and it'll give you some more information about what exactly went wrong. So in this case, there's a few important bits of information on this page right here. We have a format exception. Now, a format exception is a type of exception. There are a variety of kinds of exceptions that we can use. We can also hit View Detail and expand this, and if this was a more complex exception, we could drill down into more information. Now, this particular exception does not provide us more information, but if you run into a situation where you have a more complex exception, maybe a database query failed or something like that, and you needed to reach in and get some more information about what went wrong, this is how you would do it. So, an exception is a runtime error, but more importantly, an exception is the idea that the code you typed is not capable of continuing. So that's the most important thing to understand, is that whenever you run into an exception, you have an example of your code literally telling you, hey, wait, you're doing something that makes it impossible for me to continue. It's no longer, it's an exceptional case. It makes it so your program can't continue. That's why it stops your program. And if I was running this outside of debugging, we get this little guy, which I'm sure if you guys are Windows 7 or Windows 8 users, you've seen this quite a few times while your programs crash. This is what happens when you run into an unhandled exception and you're not debugging. You get an exception. You get an error and your program crashes. And if your program happens to be a console window, sometimes it'll dump some debug information into the console, but it's not really necessary to understand that quite yet. So let's do another exception. Actually, I think this is a compile time error. Yep, this is a compile time error. Arithmetic problem in constant value computation. Let's make this not a compile time error. Okay, so I'm going to go ahead and put in 0, and we get program is finished. Unfortunately. I was trying to, I guess C# doesn't throw on this. It doesn't? I'm doing something totally wrong here. Da-da-da-da-da. Oh, right. Ignore me. It results in infinity. Ha ha ha. I know there is a divide by 0 exception, which is why I assume this would throw, but it doesn't because it just sets the double to infinity. I wonder if I turn this into a D. Nope. We'll always be getting affinity out of this, unfortunately. Does int throw? Int throws. Here we go. That's what I wanted. Because an int doesn't have the concept of infinity. Doubles can be set to infinity. Infinity is a special value of a double. Ints can't. And then we get an exception. There we go. I was like sitting there, I was thinking, I swear I've done this before. I swear at some point one of my programs has crashed because of this exception. Stuff and things. So another example of an exception. We get a divide by 0 exception. You can't divide by 0. If it wasn't clear as to why the doubles did not, or double division did not throw an exception, remember doubles can be set to infinity whereas ints can't, which means that because ints can't be set to infinity, there's nothing for our program to do here. There's no course of action that would make sense for our program to continue. And because there's no course of action for our program to continue, well, by definition, our program stops continuing and it throws an exception. So those are what exceptions are. Let's talk about how we can handle them. And this is going to be a topic that I want to introduce to you guys, but with some very important caveats to it. Let's talk about the try-catch. Okay, try-catch. The try-catch block allows you to catch an exception. What does catching an exception mean? Well, it means we will actually be notified, essentially, when our program runs into a fatal error, and it'll allow us to recover. But again, there's some caveats to this, and I'll explain those caveats after I go over the syntax a little bit. First of all, we have a try block. A try block starts out with a keyword try, opens up some curlies, and that's it. After the try block, we are allowed to place a couple of different things, but one of those things, or one out of the two of the things we can place after a try block, is a catch block. It's important to realize that you cannot have a try block without a catch block or a finally block, but that's irrelevant. So you always must specify, at least for now, a catch block. And a catch block is just the keyword catch followed by a block of code. So what exactly happens here? Well, think of it this way. A try block, when you open up a try block and you start writing code within it, what you are essentially doing is saying, I know that there's the possibility of an error to happen here. I know this code might throw an exception. Now, if it does throw an exception, I want this code to stop executing, and I want this code to start executing. That's an important thing to realize. When an exception is thrown within a try block, execution within that try block stops. And I can prove that to you guys by hitting F5, and I can type in a denominator that is valid, such as 43, and hit enter, and we see the result of line 13, as in hey there is being printed out to the console. We see that code actually did reach this point of execution. But if I was to type in 0, which is invalid, and hit enter, we don't get line 13 executing. Line 13 no longer runs. Instead, we get an error happened. So what happened is code on line 11 executed, and it resulted in a runtime error. Then we exited the try block, found the catch block, and printed out an error has happened. So there's not a whole lot else to say about the syntax other than, just take it for granted. That's what it does. There's a few other ways that we can format our try catch blocks. You may see people have multiple catch blocks because we can filter our catch blocks by specific errors. For example, there's actually two ways I can cause an exception here. I can cause an exception as a format exception by typing in text where it expects a number. Notice on line 10 we're using int.parse and not int.tryparse. And by typing in text, this will throw an exception. That means line 10 threw an exception, which resulted in execution resuming on line 17. I can also cause another type of exception, which we've already seen, and that's if I were to type in 0, we get a division by 0 exception. With the try and catch syntax, we can actually pick and choose what kinds of exceptions we want to handle. For example, if I was only interested in catching a format exception, all I need to do is say catch, and then within parentheses, put the specific exception type that I want to catch. And then inside of here, I can be more specific. I can say a format exception happened. Now that I've added a specific type of exception here inside of my catch block and hit F5, if I were to go ahead and type in just garbage text that, as we know, will throw an exception here on line 10 because of int.parse, and hit enter, execution then resumes on line 17. We get a format exception happened. But what do you guys think will happen if I type in 0 and hit enter? Can anybody guess what's about to happen? We'll get an exception, but most importantly, we'll actually get a program crash. In this case, we get a program crash because divide by 0 exception is not being handled anywhere. We have made this catch block explicit about what kind of exception it can handle, a format exception, and a format exception is not a divide by 0 exception, which means that this catch block has absolutely no effect anymore when dealing with divide by 0 exceptions. Now I can do two things. I can either remove the type specification of my catch block, which results in it catching everything, or I can add another catch block that has a different message depending on what kind of exception was caught. So now if I hit F5 and I typed in 0, it says the world has ended, but the important thing is the program didn't crash. And that's very important. There's not a whole lot more to say about exceptions. So I'm going to start talking about some of the caveats with exception handling. I'm showing you guys examples of exception handling because you are undoubtedly going to see it in other people's code. And in some circumstances, you will run into situations where you are going to be forced to use exception handling. But never take exception handling as a tool in the same way you would take an if statement as a tool of the language. Although I am having my int.parse here and I am catching that exceptional case when the user typed in garbage, this code is actually worse than if I had used an int.tryparse. The way I should have written this code, let me go ahead and write the code the way I should have written it. I should have written it using normal C# constructs. So I should go ahead and say bool user, or how about I'll just say double input equals 0 while input does not equal 0, input equals double tryparse console read line, whoops, out input, oh come on, what am I doing now, blah 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 blah, why did I do that, sorry, double result equals 10, actually hold on, these are ints not doubles, there we go, input console write line result, I'm going to rename this to result 2. This is how I should have written the code. The reason I should have written it this way is this code prevents both of the possible exceptions from even happening in the first place. And it makes my code a lot more, I think, straightforward and easy to read. User input should always be validated by code that validates it. You shouldn't have user input be passed unvalidated into the bowels of your program and then just say, oh, well, if an exception happens, that means my user input's invalid. That's not what you should want to do. Instead, you should proactively validate your user input as close to the code that asks the user for the input as possible. So, again, this code prevents input from ever being 0, and it also prevents my format exception from being thrown if the user types in garbage. So I can go ahead and, oh wow. yeah. I'm a terrible person, aren't I? Sorry, there's been so many windows flying around here. There we go. Type in garbage all I want. I can type in 0 all I want. I can type in more garbage. I can type in a bunch of zeros plus a bunch of garbage. But until I type in something that isn't 0, the program doesn't stop. So this is how you should write that code. And you should write it good the first time as opposed to how I wrote it, because I wrote it horribly the first time, as in it didn't actually work the first time. So what's so bad about this code? You might be thinking to yourself, well, again, you are technically doing validation, I guess, but the idea of validation here is very, I guess you could say, passive. It's like, just try to do this, and if you fail, let me know and I'll show an error to the user. It becomes very difficult to present errors to the user when using exception handling as flow control. Exception handling is not a replacement for an if statement or a while loop or anything like that. Exception handling is there to handle exceptional cases. Currently, we don't really have any situations where exception handling would be useful within our application, but it is an important concept to understand because you will eventually run into a situation where you have to handle an exception. And this is how you do it. So, again, the philosophical concept of an exception is that an exception makes it so your program can no longer continue running. You should always proactively handle user input or validate user input. Exceptions are great for basically asserting that something is true. Like, an exception is good for if you're writing your own code library. You might have some code that you make an assumption on. For whatever reason, you make an assumption that a value is within a particular range, or a value isn't null, or some sort of assumption about the state of your program. And what you would want to do is you want to wrap that, or check for that state to make sure that his assumption is correct, And if it isn't, you would throw an exception, letting whoever is writing code against your library to know, even if that person is you, but you want to let them know that they've done something dumb. Okay. So, stuff and things. I just wanted to show people the syntax, define what an exception is for people, and show people how to handle them if they're in a situation where they'll need it. Again, like I said before, this today is really just a bunch of odds and ends. There's not a whole lot I can say about it. Before we go on break and get into more of a review about our methods and other fun stuff like that, so definitely stick around if you guys are having difficulty with it, I want to talk about the debugger. The debugger is a wonderful, wonderful tool that will be amazing and is one of my favorite features of C# and Visual Studio and .NET, and it makes the world a better place to live in. So, what do I mean by a debugger? Well, a debugger allows us, we've already seen examples of a debugger. What it allows us to do is it allows us to actually watch as our program executes. So what do I mean by that? Well, so I have a bunch of write lines here. And if I were to run this program, I'll get this. There shouldn't be any surprises about what this code does by now. The important thing that I'm about to show isn't about the code, it's about what we can do within Visual Studio to actually watch as our program runs. There's something over here called the gutter. It's in this edition of Visual Studio with this particular color scheme, the gutter is just this little brownish gray thingy here on the left. And what we can do here with the gutter is we can click. And what happens when we click? We get what's called a breakpoint. A breakpoint is not something that's actually part of the source code. A breakpoint is something that Visual Studio gives us. And what it allows us to do is it allows us to stop the execution of our program when that breakpoint is hit. So I'm actually going to go ahead and set a breakpoint on line 9. And again, I'm doing that by just clicking in the gutter. Then I'm going to hit F5, and it's important that I hit F5 because that actually launches our program with debugging. I'll hide my windows and put this side by side so we can see exactly what's going on. So what we're looking at is this little yellow arrow and this yellow highlighted line. That tells us what line of code the program is currently about to execute. Now we can prove that very easily. If we look at the output of our program, we see hey there line 1, we do not see hey there line 2. That's because our program is paused on line 9. You'll also notice that our program is paused, like I can't type in any input into the program right now. It's halted. It doesn't do anything right now. So what can we do with the debugger? The debugger doesn't stop at breakpoints, because once we hit a breakpoint, there are a lot of fun things we can do. Like hitting F10. I believe this is F10. 12, 11, 10. Yep. Sorry, when you have your function keys not having labels on them, you start just taking their position, or memorizing their position by granted and completely forgetting what they actually are labeled for. But yes, this is F10. F10 allows us to step forward. So when I hit F10, our execution jumped one line. It executed line 9, and we can see that it executed line 9 by hey there line 2 appearing on our console window. So we can watch as our program produces output. So I can hit F10 again, and we'll get hey there line 3. Our program advances one more line. Hit F10 again, and again, and again. Now what's going to happen when I hit F10 one more time? Well, console.read key is going to execute. And what that's going to do is Well, unfortunately, because I smashed my keyboard earlier, that input was queued up in the buffer and just got sent to read key. Let me go ahead and restart this example, and I'll show you what it should do. When I hit F10, the debugger actually is no longer pausing the program. That's because console.readKey is a blocking method. It's going to sit there inside of itself until I type a key into the input window, which means my program is no longer paused because I'm now inside of a read key invocation. So now when I hit a key, then the debugger pauses the program again. And we can see it's paused because there's this little orange border around Visual Studio. That's a new addition to 2012. So now execution is on line 15, but there's actually nothing that line 15 does. So when I hit F10, our program finally exits. Okay, let's go through that one more time, and I'll show you guys little toolbar buttons that do the same thing. F10 maps to this key, or this button right here on the toolbar. You can also, I believe, go into the debug menu and say step over. Now, instead of just hitting F10, I'm just clicking on step over. And step over does just what it says on the tin. It executes the line of code, but it doesn't jump into the code that may be executing as a result of this line of code. Now, what does that mean? Well, let's throw up a method. I don't mean literally throwing up a method. That would be unpleasant. Alright, so all I want to go ahead and show people right now is the concept of stepping into. So okay, so what we have right here is an example of a simple program that has three methods in it. We have our entry point, we have say things, and we have say things nested. Say things invokes say things nested. So when we run this program, we'll get the output that we expect. That's not what's important here. What's important here is that if I were to put a breakpoint here on line 9, there's going to be a difference between me clicking on step over and step into. So watch what happens when I hit step over. All of a sudden, everything in say things, as well as the nested invocation to say things nested, gets executed. So let me step over again so that I'm sitting here on line 12. Now, if I hit step into or F11, watch what happens. I'm actually following the execution of code all the way down to line 28. Now, if I continue to hit step over, I'll resume executing the program as you'd expect, but within the say things method. Then, when I hit step over one more time on line 34, I jump back to line 12, now that it's executed, and if I hit step over, we'll continue going on our way. So step into allows us to go into a method definition. In fact, we can step into something that we've stepped into. So if I repeatedly click on step into, we'll eventually find our way all the way down here on line 36, the say things nested method, which is invoked here in line 31. So again, the debugger, I'm just showing you guys what you can use the debugger for. It is one of the most important tools for understanding your program. This is not all it can do. So let's talk about something else. Before I get into watches and other fun stuff like that, I want to talk a little bit about the call stack. The call stack in any programming language is the concept, or in any operating system or programming language. Hold on, let me blah 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 blah. Give me 1 second here in my little... Should probably have set this up before class, but I totally forgot. Where are you? You're somewhere, right? You're in here, probably. And you're probably down... No, you're not here, are you? Oh, there you are. Or not. Come on, Visual Studio. You can do it. Oh, there it is. Wow, I can't believe I missed that. Let me go ahead and I'm going to keep just my code enabled. So ignore what I just did. I just made my call stack look like probably what your call stack looks like. So what is the call stack? Well, the call stack is a stack that represents what methods have been called. You'll notice that many bits of programming terminology are very self-descriptive. So a call stack represents all of the methods that have been invoked up to our current point. Right now we have 2 entries in our call stack. We have external code and main. I'm not going to worry about external code. External code is going to be all the stuff that the CLR actually invoked before we got to our entry point. But watch the call stack. I'm going to go ahead and make this side by side so you guys can see the output of the program. Watch the call stack as I enter a method. When I've stepped into say things, all of a sudden our call stack grew. And it's telling us that we are in a method called say things, and then before we were in say things, we were in main. And if I jump into say things nested, our call stack grows again. We have say things nested at the top, say things, and then main. Now the cool thing about the call stack is it allows us to double click on these entries and see exactly where this method was invoked from. So if you ever find yourself debugging a method and you're wondering where the error actually happened, then you could always go all the way up the call stack. I'll show an example of that because I know what I just said was probably one of the most vague things I've said in this entire class. Let's say I have a method, static void my method, that takes in an int my number. And all it does is it says int result equals 43 divided by my number. I really like that 43 number for some reason. Let's say I invoke my method here with the value 20. That's not going to throw an error. Say I invoke my method here with the value of 10 and the value of 5. Then let's invoke it with the value of 0 here on line 22, and then let's invoke it again with the value of 53. Okay, so I've invoked my method multiple times. However, line 22 is going to cause an exception to happen within my method, but watch how we can debug this. See, if I hit F5, we get an exception here on my method. But what we're looking at right now isn't that useful because we don't know who invoked my method. With the call stack, we can find out. All I gotta do is double click on this next entry in the call stack and I can see exactly what line of code resulted in my method throwing an exception. Okay, so that allows us to navigate the stack. The stack is very important. So just to recap what we've talked about so far, we have set breakpoints. We can set breakpoints on any executable line in our entire program. We can debug our software. We can use F10 or this button up here to step over. We could use F11 to step into. We can watch our call stack grow so we know exactly the chain of methods that were invoked to get to the current location, and so on. Before we talk about inspecting variables, there's one more thing I want to discuss, and that's another very common sort of there's a very common sort of way that you would navigate the debugger. Let's talk about the F5 key. Now, I know most of you probably already know the F5 key as the Start Debugging button, but when we're in debugging, it means something else. It means continue. So let me go ahead and comment out this line of code that's going to throw the exception. And then I'm going to hit F5. And then now that I'm debugging, I'm going to hit F5 one more time. What happens is the program will continue executing. This isn't a step. This is a just keep on going, doing what you've been doing, and stuff and things. One of the most common things you'll do while debugging isn't necessarily stepping over and stepping into. It's setting a breakpoint while we're debugging, and then hitting F5 to jump to that breakpoint. I believe there's also a run to cursor button, but I've never used the run to cursor button for some reason. Sue me. Also, it will stop execution if it runs into an error. So, fun stuff. I'll just show the run to cursor button then. Someone told me where it is. So, they say right click and... I hate this stupid thing. Control F10, run to cursor. Although honestly, considering how how incredibly massive this context menu is, I would say setting a breakpoint's actually probably faster. But anyway, so yeah. Next thing, this is just for fun for you guys. You guys want to see something crazy? Go up here, hit F5, go up here, hit F5, go up here, hit F5. Yes, I'm actually changing the next line of code that's going to execute on my program, and I'm repeatedly running the same code over and over again. Another feature I've never used. I would be very careful with this feature because there is a very big difference between running your code and debugging and actually editing your code. In that, I don't know, it's a very difficult concept to explain, but it feels very dirty changing the next line of execution because it could give you it could result in you making assumptions about your code that aren't necessarily true. And 99.9% of the time a program crashes is because somebody made an assumption that wasn't true. Okay, so that was just a fun little thing. Let's go back to debugging my method. Pretend that my method, this invocation on line 22, is buried somewhere very deep within our program. Then also pretend that line 34 is a very, very complex algorithm. So when I hit F5, because we're pretending that this line right here is a very, very complicated algorithm, we need a little bit more information to debug this problem than what we might have by just navigating the call stack. And that information is provided to us through hovering over variables and parameters. Within the C# debugger, or really any interactive debugger that you could possibly use, if you hover over a value or a variable, you can actually see the value of that variable. That's not the only way to see data. I can also look at my autos and my locals, in which case autos and locals are the same thing because this program is so simple. But my autos and locals allow me to actually inspect exactly what data is in each one of my variables. Not only that, I can say, okay, well, I see my number is 0. I wonder if my program is crashing, or hold on, it already crashed. So I'm going to set a breakpoint here until we hit a number of 0. I wonder if I change the value of this variable in debugging, if it will cause my program not to crash. And then I hit F5. So, straightforward, we can look at the data of our software. And that's really all there is to it. I can throw up another example here. There's special little debugger windows for different kinds of data. Like, for example, if I had a list of string called whoa, which is the worst name that you could possibly use for a list of string items. And then I set a breakpoint here, hit F5, and I looked at whoa. Notice how I can expand it and look at every single item within whoa. So I can also do the same thing by hovering over the variable, and I get this little pop-out window. There's not much more to say about it. Wherever you are in your program, you could look at the local variables and variables that are also in scope and inspect them, view their data, and even alter their data. So I don't necessarily know if there's much else as far as basic debugging to go into. There's a lot of fun stuff. We can do watch expressions if we wanted to. Watch expressions. Actually, let's do one. Let's do a watch expression. They're fun. I'm going to go ahead and put in a watch expression, and I'm going to give it the name of whoa.count. Look what happens. It says, first of all, whoa is null. Well, when I hit F10, whoa now has a count of 0. When I hit F10 again, it now has a count of 1, 2, 3, and so on. Another really fun thing that I doubt anybody here is going to use, but you might as well know it exists, is the intermediate window. I use the intermediate window a lot while debugging. What does the intermediate window allow you to do? It allows you to type in any C# code that you want, hit enter, and have it execute. Immediate window, sorry. I saw, I don't know what I saw. I saw something and it wasn't what I was supposed to see. Anyway, so I can actually type in arbitrary C# code into the immediate window and watch it execute. And I know it's executing because look at my watch expression over here. It's increasing the count of whoa. If I go back to locals, I can expand it and I can actually see that I'm altering the data by typing in C# code. I can really type in almost any C# code that I want, including C# code that results in an exception. Well, that results in a compile error. I could do int.parse blah, and I get an exception. Input string was not in the correct format. So with the immediate window, you can sit there and type in any C# code you want, with some caveats. Again, you can't use lambdas. I believe you can use anonymous delegates. I don't believe you can use, no, I think that's actually a new feature of 2012 is that you can use extension methods. Actually, let's see if we can use extension methods. I can't remember. Oh yeah, we can. But we still can't use lambdas. Anyway, the point of that was, again, you're not going to use the immediate window very often starting out. But know it exists, because it might really be the one thing that's the difference between sitting there bashing your face against the keyboard and trying to fix a problem and being able to understand what exactly is going on. The main things that people here are going to be using as they start writing code are the concepts of stepping into, stepping over, setting breakpoints, inspecting variables in the pop-up windows, the locals, and the autos. Now, if you want to get fancy, you could put in watch expressions, and if you wanted to get super fancy, you could use the immediate window. But that's it. By the way, I just stopped debugging. There's two ways to stop debugging. I can either hit this red square up here, or you can hit Shift F5. Either way. Okay, so that wraps up all the new fun stuff I wanted to go over today. When we get back from break, I want to go over some method review stuff and some collection review stuff, and hopefully help some people out. Again, this is going to hopefully a very light class for people compared to what happened last week and what's going to happen next week. So I will be right back. And we're back. So, like I said, this week is all about wrapping up some loose ends, and there's one loose end that is really starting to irritate me. And that is the logical operators. So, it's very common that in programming that we might want to have an if statement that has more than one bit of criteria. What I mean by that is, let's say we have a number, and that number is retrieved from user input, and we want to see if that number is within a particular range. So we want to make sure that number, let's say we want the number to be larger than 20, and we want the number to be smaller than 40. So if I run this program, it's very simple. If I put in 4, it says number is not between 20 and 40. If I type in 21, it says number is between 20 and 40. Pretty straightforward. But we can write this in a way that doesn't make me want to cry. And that is, we can use some of the logical operators to make our code a lot clearer. I'm going to change this if statement. I want the if statement to say, is the number larger than 20 and is it smaller than 40? And if it is, I want to print out this message. So how can I do that within the same line? Well, that is very easy to do with our logical operators. One of our logical operators is the logical AND operator, not to be confused with the Bitwise AND operator. That operator is specified with 2 ampersands. So what I can do is I can say if number is greater than 20 and number is smaller than 40. That's how it's printed out, or that's how it's pronounced. If number is greater than 20 and number is smaller than 40. Which means our program now does exactly what it did before, but it's a whole lot shorter. There's one thing that people will get confused about that I've seen so many times. They will try to write this. Because in English, this makes sense, right? If I read this out loud, it'll say, if number is larger than 20 and smaller than 40. That makes sense as far as English is concerned, but it doesn't make sense to the computer. What we have here is an operator that is just like let's say the addition operator. The addition operator is an operator that has 2 operands, has 2 values, one on the left and one on the right. And the AND operator is no different. This has 2 values, one on the left and one on the right. Which means we have to specify a value on the right. This is not a value. This is a syntax error. We have to, because remember, the AND operator wants a value on the left. Let me go ahead and make this very clear to everyone using parentheses. And it needs an expression on the right. But this is not a valid expression. Our less than operator needs a left value. It always needs a left value. There's no way to get around it. You can't write code like this. Now, just off a crazy tangent, you technically can in languages like F#, where we get an awesome example of currying, but that's obviously not what we're talking about today. In C#, this will always be invalid. We must specify a value on the left of this. So we actually have an example of 3 expressions. Let me break those expressions out for you guys. We have one expression, which is number is larger than 20, and this expression equals number is greater than 20. We have another expression, number is smaller than 40, which is this. Then we have another expression, number is between 20 and 40, which is going to equal number is less than 20 and number is smaller than 40. This expression right here, whoops, this expression right here is basically the longhand form of this expression right here. So it's technically three expressions. We have our larger than 20 expression, our smaller than 40 expression, and our combination of the two using a logical AND. So, yeah, that's that. So let's talk about the other logical operator that will be used very commonly, and that's the opposite of the AND, that's called the OR. So let's rewrite this. I'm going to rewrite this to be number is smaller than 20, and then I'm going to do number is greater than 40. Then I'm going to change this to number is, how about number is smaller than 20 or greater than 40. Right now this code won't actually work. So I'll go ahead and reverse this, because that's basically the inverse of what we're just doing. Right now this code won't work because what we're doing is we're saying number is smaller than 20 or greater than 40, but our expression is number is smaller than 20 and number is greater than 40. Grather? Did I really type in grather? Number is greater than 40. Okay, so what we need to do is change our operator from an AND to a OR. What does an OR operator look like? Well, it just looks like two pipes. By doing this, I have now changed the expression to be that. What does the OR do? Well, the AND makes it so that if both the Booleans are true, it'll return true. If either of the Booleans are false, or if both Booleans are false, it'll return false. The OR will return true if one of these Booleans is true. So let's go ahead and inline this guy so that we can see an example of just using the if statement without it all written out. And what we get is number is less than 20 or number is greater than 40. So that's really that. Not a whole lot to say about that. I mean, you can change as many of these as you want. I can say if number is smaller than 20, or number is greater than 40, or true equals false, or console read line equals whoa. I mean, I can just go on forever and chain as many of these as I want. And that's really all I really want to talk about with our logical operators. There is going to be a situation where you run into order of precedence problems. Just like in math, every operator has a precedence. And the higher that precedence, the sooner that expression will be evaluated. We can see an example of order precedence by doing something like int my number equals 20 plus 4 times 2. And what this is going to result in is 28. It's not going to result in 48. Or, sorry, 48, yeah. It's going to be 28. And that's just because of the order of operations. So, all operators have an order of precedence, and that is not exclusive to mathematical operators. It also applies to logical operators. Most books will sit there and bash the order of precedence into your face for hours and hours and hours, but in all honesty, it's best to go forward just realizing that it's there, and then working out each individual issue you run across by adding in a combination of parentheses, because parentheses will increase the precedence of any expression. So, Again, it's just something you have to get used to, something you have to gain an intuition towards, something you need to practice, but be aware of it if you run into a situation where you have a compound expression not behaving the way that you expect it to. I'm not going to sit here and spew out the C# specification to everybody, because you can look that up online. People are talking about the bitwise operators. I'm not going to talk about the bitwise operators because the bitwise operators are used significantly less often, and they're useful for certain scenarios, and they can provide some additional complexity that I don't want to get into. But I will say this: if true or false, this is the logical operator of AND. That is the bitwise AND. The difference that you need to realize is that the logical AND will have 2 ampersands, the bitwise will have a single ampersand, and they do completely different things. Okay, so I think that's the last sort of loose end I wanted to wrap up today. There's not a whole lot more to say. For future people watching the video, if you guys are having issues, obviously post on the forums, review the particular lesson that we went through something with. For people here, I think it's about time to take a step back and field some questions for people who may be still confused with things, and hopefully we'll get that all wrapped up. Because remember, next week is going to be some intense stuff. So, today we talked about enumerations. We have enumerations which allow us to create a user-defined type, which is awesome. Enumerations allow us to define a finite set of values for a particular variable. We talked about exception handling, where we can handle particular exceptions. I talked about the syntax about exception handling and some of the caveats that you have to keep in mind with exception handling, and that exception handling is not for flow control. It's not a replacement for an if statement or a while loop or user validation. We talked about debugging. So we looked at the debugger, we went through stepping over, stepping out of, breakpoints, continue program execution. We talked about the local window, the auto window, the immediate window, and all that fun stuff. And then we wrapped up talking about some logical Boolean operators. So I think that just about wraps up everything I wanted to cover today. So I will see all of you future people next week for probably, undoubtedly, the most difficult lesson of this entire class. So be prepared. I'll see you guys later.